Here we have an example of a binomial distribution, and I'll show you, work through how to use the tables that are in your notes, a set of tables for binomial, because sometimes the numbers are so big that it makes the working, particularly how to calculate it, quite impossible almost. So we need to know how to use the basic table, set of tables that will give them to you to work these out. So we have an example here where we've got 20 light bulbs and someone's done some testing on them, and we know the probability that one of these failing is 0.1. And we want to know the probability that at least 17 will be working after a couple of months. Alright, so we know that 0.1 they're going to fail. First of all, we work out what n is. N is the number of trials. Now, each bulb is considered to be a trial, so there are 20 bulbs, so there'll be 20 trials. We know that the probability of a failure, which denote by lowercase q, is equal to 0.1. So the probability of success that it's going to be working is 1 minus 0.1, which is equal to 0.9. Now, probability of at least 17 working, and sometimes the wording of these can make it a little bit confusing. At least 17 working is the probability that you're going to have 17 successes, plus probability, at least 17 includes 17, plus probability of 18, plus probability of 19, plus probability of 20. So you've got 17 successes, 18 successes, 19 successes and 20 successes. So you could work these out, like for instance 17 successes would be equal to 20 C17 times the probability of success is 0.9, the power of 17. If you got 17, the power of 17, those numbers are the same, times 0.1. If you've got 17 successes, or in other words working, you're going to have 3 failures. 3 plus 17 is 20. Plus, then you could work out probability of 18, plus probability of 19, plus probability of 20. So you could actually just change these numbers and work out 18, 19, 20, add them up. But there is a table that in exam situations you'll be given, and let's just put the table here so we can have a look. So this is the binomial probability table. If you have a look at it, you've got the probability of success across the top, so it'll only work for p equal 0.2, 3, 4, 5, 6, 7, 8, 9. And here are your number, R is your number of successes. So, and here is your number of trials. So it'll only work for n equals 5, 10 and 20. Now, our example that we've got with the light bulbs, we've got 20 light bulbs and we've got 17, 18, 19 and we've got 0.9 as a probability of a success. So if we go to the bottom part of the table, we can identify here that n equals 20, this is the number of trials. So this is the number of light bulbs. And we know the probability of them working is 0.9. So we're going to go across to there, and we want 17, 18, 19 and 20. So rather than work out that 20C17, etc., the go across here, and then we've got 0.9 for the p-value, the probability of success, 17. So we've got these values here. 0.190 is the probability of getting 17 light bulbs lasting. 0.285 is 18, 0.270 is 19, and 0.122 is the probability of 20, all 20 of them working. So we can just read those values from the table and put them in and add them up. So go back to our working here. So instead of working this out without a calculator, it's virtually impossible to take your quite a long time. So probably 17 successes going to the table would be 0.190 plus 0.285 plus 0.270 plus 0.122. So that would be the probability that you're going to get all 20 of them working. Okay, so those numbers then simply needed to be added up, and we get 0.867. So we've got almost an 87% chance that all 17, 18, 19 or 20 of them are going to work for the time